I recently had the opportunity to record a podcast with Robert C. Martin. Unfortunately, due to unexpected system audio issue, my microphone was muted, so I'm doing a voiceover. So here my first question from Uncle Bob is, if AI can generate code instantly, what does software craftsmanship mean in 2030? So let's see how it responds.
So the first thing to realize is that the AI agents are pretty good at writing code. They're not great at it. They're not perfect at it, but they are pretty good. They will do what you tell them to do within certain parameters. But they're also undisciplined, chaotic. They lie and cheat, not intentionally, but they do not do what they say they will do, and they forget their rules, and they are very much like extremely intelligent children. Therefore, they need an adult to monitor them and to correct them and to supervise them. Now, if we programmers are going to enhance our productivity by using the agents, we are not going to be able to review all the code that comes out of them. Because if we did that, then we would just slow everything down to our speed. So we need a way to allow these agents to write code and for us to manage and supervise that without forcing ourselves to read every line of code that they produce. And there are many, many ways to achieve that goal. And what I do is I make sure that I have tools. These tools are just programs that are written, and those tools analyze the code that the agents produce and keep it very, very strictly organized. So, for example, I have one little tool that checks for duplication. It looks through the entire code base and it looks to see if there are similar functions nearby. And if there are, it will alert the agent and say, "Oh, agent, you left duplicate code there." And then the agent will go back and look and say, "Oh, yes, I did." And it will unduplicate it. It will find an abstraction that is appropriate to merge the duplicated code. That's just one example. But there are many, many examples of tools like this that will force the code into a very reasonable structure. We programmers are responsible for providing those tools, monitoring those tools, making sure that the agents are using those tools, which sometimes they forget to do. But so it's a very interesting process. We are still the programmers. We are still the ones managing the process. We are still the ones thinking of the designs, going through the structure, making sure that the modules have the right shape, making sure that the dependencies are still correct. We do that indirectly by probing with the AIs, asking the AIs and telling the AIs, but we're still responsible. And in the end, if anything breaks, it's our fault, not the AI's fault. So we maintain all the responsibility and all the accountability. So you asked me a very specific question. How is this going to affect us? And the answer to that is we will become slightly more high level than we were before. We will not care so much about syntax. Syntax will be the domain of the agents. We'll let them worry about syntax. Everything else we worry about. We worry about code quality. We worry about code structure, module structure, architecture. We worry about all of that, which is good because the one thing that humans aren't great at and that they are great at is syntax. So it just takes that one little thing away from us and allows us to move faster.
Now here, talking with Uncle Bob about moving faster. I'm talking to him with that, with the AI assistants. Expectations have gone really, really far. Like everyone is expecting to complete your tickets, your bus as one day in few hours. So there are lots of expectations of businesses right now, and I'm also giving him some prayers in between. I'm admiring him also in between because he's one of our heroes who have shaped our career and the way we think. And my next question from Uncle Bob would be that can AI generated code ever be considered as a clean code, or does clean code requires human intent? Unfortunately, due to unexpected audio issues, the recording had not gone exactly as planned, but the experience is still incredibly valuable. The discussion throughout the podcast reinforced the importance of software, continuous learning, and thoughtful engineering practices. So, I'm just going to do a voiceover and also
Clean code still
let
requires human intent. The AIs are not very good at this, um, or I should say they'll happily cheat, and they will happily cheat more than a human would. They have no sense of morals. They have no conscience. They have no sense of the future, and so they don't care if they cheat. And so it is the responsibility of the programmer to maintain clean code. Now that I do that with tools, I do it with spot checks. I will look at bits of the code. And if I see, I look at a module and I see that module is relatively clean, then I know that my tools are doing the right work and that the agents are constrained to produce very good code. Is it the best code? No, it's not. The code that comes out of the agents is not as clean as I would like it. On the other hand, I'm not going to fuss too much about that because the code is now their problem, not my problem so much. So I'm much more focused on the module structure and the module clarity and the architecture and higher level things like that. Do we as programmers still care about clean code? Yes, we do, but somewhat indirectly. Now, you had mentioned something earlier. You said that the expectations are high, and that's true. Everyone is now expecting programmers to go faster. That does not mean we have less time because the agents buy us an immense amount of time. They get things done very, very quickly. So we can take advantage of that. We programmers can take advantage of that to take some time to work through the issues of architecture and design and quality. And we will still be going faster than we were before by probably a factor of 2 or 3 or 4, maybe even 5, depending on how good we get.
here my next question is from Uncle Bob is which clean code principles become more important in an AI assisted world?
I'm not sure that any of them have changed their importance. A few of them have shifted a little bit. So, for example, one of the principles that I held to very, very strongly was short functions. I like my functions to be nice and short. I have relaxed that with the AIs. Not a lot, but I relaxed it a little. And the way I measure that is with another tool which measures cyclomatic complexity. Cyclomatic complexity is just the number of pathways through a module. And when I am writing code, I like to restrict that to 4, which is a very short module. There can be 4 independent branches through the module. For the AIs, I restrict it to 6. They seem to be able to deal with that just fine. So I pulled back a little bit on things like the size of functions and the number of arguments I'll let them pass a few more arguments. I don't want them to pass 20, but I'll let them pass a few more arguments. I used to limit that to 3. Nowadays, if they do 4 or 5, I'm not going to worry about it. They are better at this than we are. They are better at looking at functions and internalizing them than we are. So I let them have a little more leeway. On the other hand, things like names, the names still need to be good. And by the way, the agents are pretty good at choosing names. The names need to be good. I let them write more comments than I like, but the agents actually write good comments, and the agents use those comments when they read the code. Unlike humans who ignore the comments, the agents actually read the comments, so I let them leave more comments in the code. But overall, all the rules still apply. There's just a little bit of tuning that needs to be done to work well with the agents.
So here my next question is, will AI increase or decrease technical debt over the next decade?
I believe it will decrease it rather substantially, because the way to take advantage of the AIs is for us to focus on technical debt, the creation of it. We can now unburden ourselves of the problem of writing all of that code, and now we can focus on keeping that code really high quality, which we are going to have to do, because the amount of code that's going to be produced over the next decade will be 10 times the amount of code that we produced in the previous decade. We're going to be producing a lot of code, and we're going to have to keep it under control.
Here my next question for Uncle Bob will be, if coding has now become cheap, does software architecture became the most valuable engineering skill?
That is certainly true. By the way, it's always been true. It's just the agents have now amplified it even more. But the skill in coding has always been less valuable than the skill of architecture and design. Always. It's just even more so now.
Here my next question from Uncle Bob is that, if you were starting your career today, how would you prepare for an AI assisted future, especially for new joiners? Because it's very important. A lot of new joiners are using AI aggressively. So let's get an advice.
I consider the agents to be power tools, and very dangerous power tools. And a novice with a power tool loses fingers. So my answer to your question is, for the first few years, they should not use agents at all. Learn to code well, learn the rules, learn craftsmanship, become good at it, and then start using the power tools gradually and probably under some supervision.
My next question will be, do you think that AI will reduce the demand for developers or simply change the nature of their work? Because on the LinkedIn, we see a lot of chaos regarding jobs, regarding AI, everything. And let's see his perspective on this.
Yes, AI will vastly increase the demand for programmers. They will need many more of us because the agents will outrun us. We will be able to create vastly more code much cheaper than before. And when things get cheaper, people want more of them. So people are going to want more code, and that there will be more programmers. It will, and this, by the way, this is the way this has always worked. Every time in the software industry something has gotten easier, the fear was that programmers would be replaced, and what happened instead is that we had more demand for programmers. This has happened many times in the last 70 years. Every time something got cheaper, we needed more programmers to deal with it. Right now, there are some companies that are laying off. And the reason they're laying off is that they're scared. They don't know what's going on. So they don't quite know how to deal with the changes that are coming in. Some of the companies that did do some layoffs are now reversing that and trying to hire as many programmers as they can get.
My next question from Uncle Bob will be regarding test-driven development in AI-assisted code.
Yeah, absolutely. Although it changes form slightly. I have all my agents do test-driven development, uh, but they do not do it the way I do it. I do it in tiny little steps. The agents won't. They just won't. I've tried to get them, and they won't do it that way. What the agents do is that they will write a whole bunch of tests, and they will implement a whole bunch of code, and it seems to work fine. So I'm going to let them do that. That's what they prefer to do. I make sure that every bit of code has a unit test against it. So they can't write the code until they write the unit test. That's the first rule of test-driven development. And then I have a tool that I run, which is called a mutation tester. And the mutation tester reaches into the source code. It makes changes to the source code. It will change a less than to a greater than, or an equals to a not equals. And then it will run the tests, and it will expect the tests to fail. If the tests do not fail, there's a missing test, and the agent will write a test. This is an old approach, which we tried 20 years ago, but it was so labor intensive and so CPU intensive that it was very hard to do. Now it's really easy. Now you just have the agent run the mutation tester, and it will instrument the code with every kind of test you could imagine. So the number of unit tests goes up dramatically, and the code becomes almost 100% covered through every pathway, which is very, very good. Then I have the agents collaborate with me to write acceptance tests. And these are usually in the form of Gherkin, given, when, then statements, behavior-driven development, BDD, all that kind of stuff. Very nice little statements, given, when, then statements, which I have the agents parse. So I've got a parser that will parse it, and then it will turn that into more unit tests. So now I have unit tests that test the code every which way because they're mutated. And I also have human-oriented Gherkin tests, which are also turned into unit tests. And that provides an immense amount of testing. It's still cheap. It's still easy. The agents do it very, very quickly. And it creates a massively overloaded testing suite.
My next question is, what aspect of software development do you think that AI will never replace?
Um, so it's an interesting question because it's difficult to identify the parts of software development that are automatable from those that are not. And so there's this line, and I don't know where the line is, but there's a line where everything above that line must be done by humans. And everything below that line could be done by a smart enough machine. That line has something to do with spirit and soul and human creativity and integrity and morality and responsibility. It's difficult to draw that line. It's difficult to say that here's the line exactly. But take a look at everything we value about human beings and everything that we use that are machines. And that line is somewhere right around there.
Okay, my next question for Uncle Bob is: are you optimistic or pessimistic about the next generation of developers growing up with AI co pilots?
Oh, I'm massively optimistic. I think the next decade is going to be tremendous. I think we're going to see wonders upon wonders happening in the next decade, all over the place. So yeah, very very optimistic. I hope I live to the end of the decade to see it all.
Here I'm giving lots of prayers for his health, for his long
So far,
life,
so good.
for his happiness. And also, I will be asking next question: what are the biggest risks of developers becoming overly dependent on AI?
The biggest
Uncle Bob always insists on software quality.
Yeah, the biggest risk is trust. Um, you have to have a certain amount of trust. Otherwise, you would be reviewing every line of code, every character of code. But if you trust too much, you're going to let them get away with too much. So, and they will try to get away with as much as you let them. And I don't mean to imply intent there because the agents do not have intent. But when you focus an agent on a task, the agent does focus to the exclusion of everything else, which means that the agent will effectively cheat. So you, as the programmer, cannot trust implicitly. You have to be skeptical. You have to try and anticipate what the agent will do wrong or get away with. You have to kind of see into the mind of the agent, if the agent even has a mind, and infer how the agent is going to do this wrong. And then you can ask it questions. And they're very good at answering questions like this. You can, if the question is deterministic, they're very good at answering the questions, right? So you, for example, you can say, did you separate the user interface from the business rules? And they'll answer that. They'll answer it perfectly, and they'll probably say, oh, and I should have. I'll be right back. And then they'll come back with a nicely separated set of modules. On the other hand, they are not good at answering questions about their intent. So if you ask them, why did you do what you just did? They will not answer that truthfully because they don't know why did what they did. But they will come up with a plausible answer, which you must not trust.
My next question for Uncle Bob will be from the audience. Okay, do you think AI will eventually make clean code principles less critical, or will poorly structured code bases become even more of a liability when AI tools are layered on the top?
Yeah, no, all those principles become more important. All the solid principles, all the clean code principles, everything becomes even more important because we are the ones controlling that, and we're going to have to go very fast.
If you were starting your software career today in the age of AI, what would you focus on most?
Once I had mastered just raw coding for 2 or 3 years, then I would be then I would be focusing on how to how to trust the AIs, how much to trust them. I would probe them. I would have them produce simple little problems. I'd investigate what they did and how they did it so that I had an insight into how they would behave on larger problems. I would spend a fair bit of time outside of work. I would spend a fair bit of time simply playing with them, getting some idea of how they work and why they work and what they do right and what they do wrong, so that you can develop the right level of trust in what they do.
Okay, here I'm summarizing the last question that how should developers prepare themselves today to remain effective and relevant?
Comes is going to involve how adept you are at using the agents. That's where it is going. So there's a cohort of developers right now that are refusing to use agents, and I think they will be left behind. Those who are right now investigating the agents, I think, are the ones who will be in the lead. That's how I'm betting.
Also, we talked about we should be very good at writing prompts, which we
The
agreed
use of
upon.
agents is a skill, and it is not a simple skill to acquire. There's a lot to learn. So yeah, I would strongly advise lots of playing, lots of investigation, lots of understanding what the strengths are and what the weaknesses are, and where you can trust them and where you cannot. And you should try a few different models. Try Codex, try Grok, try Claude, try a few and get a feel for how they differ, because they do differ.
Here I'm also asking him one question that should we go and learn like AI models, how LLMs are working in depth, being software engineer, how deeper we should learn about AI.
I don't think it's necessary for us to be deeply aware of the AI algorithm. Um, a, a, a reasonable knowledge of it would be fine. The basic idea of predictive text, I think, is a good thing to know. We need to understand that these algorithms are stochastic. They work on probabilities. They work on possibilities. They're not deterministic the way we are used to. We are used to computers giving us deterministic answers, and the AIs don't. They give us probabilistic answers. So we should understand that, and we should understand why that's true. But beyond that, I don't think you need to know the matrix math or the calculus or any of this strange, bizarre stuff that the AI scientists are deeply invested in. This is very similar to the way compilers work. We programmers are not super knowledgeable at how code is generated by a compiler. Something similar to that.
Because this session was really great. He's like a master for me. I mean, when I see chaos among people, I always approach him, or when I read his books, or I have a question, I usually approach Uncle Bob for his views. And thank you, Uncle Bob, for always coming, always showing up. Thank you so much. Okay, at the end of the podcast, I'm discussing an idea, business idea, which is going to impact hundreds and thousands of lives in a very positive way. And it's not recorded, so that's about it. Thank you. Thank you, everyone, for watching.